Hi everyone. In this video, we're going to look at some more trig equations. So at this point, you know how to solve the basic trig equations, and so we're just going to look at a few more scenarios that could happen and the ways that you might approach solving the equation. Okay, so the first scenario we're going to look at is how do we solve equations with reciprocal functions? So remember, our reciprocal functions are secant, cosecant, and cotangent. Okay, so actually we're going to solve these initially just like we did the basic trig equations with sine, cosine, and tangent. We're going to isolate the trig function. So in my first equation, I would actually start by adding 2 on both sides. And we would get secant of theta equals 2. Okay, then we're going to use the fact that secant is the reciprocal of cosine. So that means that if secant equals 2, then cosine of theta would have to equal 1/2, which is the reciprocal of 2. And then from there, we're just going to approach it the same way we've been doing. We're going to use our inverse trig function to solve for theta. We're going to go to our unit circle and think where, meaning which angle, is cosine 1/2, and that is actually at pi over 3. And then because we're solving for cosine, we're going to put plus minus in front of it and then add the 2n pi. Okay, in our next equation, we're going to start by adding square root of 2. Again, to isolate the trig function. And then we're going to use the fact that cosecant is the reciprocal of sine. So we can rewrite this as sine theta equals the reciprocal of square root of 2. Now, if we make square root of 2 a fraction by putting a 1 under it and then flip it, we initially get 1 over square root of 2. But you might not recognize that value from your unit circle. But if we rationalize the denominator, then we get sine of theta equals square root of 2 over 2. All right, and then we'll use our inverse trig function to solve for theta. And then we'll think to our unit circle, where is sine equals square root of 2 over 2? That would be at pi over 4. Plus 2n pi. And then we also have another angle if we do pi minus pi over 4. And then find a common denominator. 4 pi minus 1 pi gives us 3 pi over 4 plus 2n pi. Okay, so these would be all the solutions. So that's really all you have to do when you're solving for reciprocal functions. After you isolate the trig function, you just change it to sine, cosine, or tangent and set it equal to the reciprocal. Okay. All right. The next scenario we're going to look at is solving by factoring. So, factoring is a good technique in many scenarios when we're solving equations, including trig functions. Okay. So remember, whenever we're solving by factoring, we always want to set the equation equal to 0 first. And we're going to do that as well with our trig equations. So to solve the first equation, I would start by subtracting cosine theta on both sides and then setting it equal to 0. And then, you guys, this is one where we're factoring out the greatest common factor. So what's common to both terms? Well, I hope that you're seeing cosine theta is common to both terms. So we can factor out cosine theta, which will leave us with sine of theta minus 1 equals 0. And then after we factor, we just set each factor equal to 0. And then we'll just solve each equation separately. Okay, so we've got cosine theta equals 0. We're going to go ahead and use our inverse function to solve for theta. And then we're going to think back to our unit circle. Where is cosine equal to 0? And cosine is 0 at pi over 2. And then remember we put a plus minus in front because we're solving for cosine. All right, then we're going to solve our second equation. Here we're going to have to add 1 first to both sides. We get sine theta equals 1. We'll use our inverse to solve for theta. And then we'll think to our unit circle where a sine equal to 1. Well, that actually occurs at pi over 2 plus 2n pi. And we have all of our solutions. Now, honestly, we probably could condense that just to positive and negative pi over 2 plus 2n pi, but, you know, we've definitely got it all covered. So, all right, let's look at the second equation. So, again, we want to start by setting the equation equal to 0. So, I'm going to subtract the 2 sine theta and subtract the 3 and set this equal to 0. All right, and then you guys, we're actually going to solve this one like we would solve a quadratic. Because notice how we have a sine squared in the first term, and then sine in the second term, and then a constant in the third term. Yeah, we can actually solve this like a quadratic. So we break it up into 2 factors. Instead of each factor starting with x, like if we were solving a quadratic equation, each factor is going to start with sine theta. All right, and then we're going to think factors of -3 that add to -2, and so that would be -3 positive 1. And then we will set each factor equal to 0. And we'll solve each equation separately. So when we solve the first equation, we would maybe start by adding 3 to both sides. I don't know, you might even try to evaluate the inverse, but you guys remember, the domain for inverse sine is -1 to 1. Okay, we can't evaluate inverse sine of 3 because 3 is not in the domain. So actually for this one, we get no solution. But I think we'll get a solution for our second factor. Subtract 1 on each side. Okay, use your inverse. And then think to your unit circle. Where is sine equal to -1? Well, that is actually at negative pi over 2 plus 2n pi. Okay, so that's factoring. You know, it's pretty similar to how we have factored with other equations. You want to set it equal to 0, factor your left side, set each factor equal to 0, and then just solve each equation separately. Okay. Next, we're going to look at trig equations that have multiples of angles. Okay, now remember, theta is the angle. So you'll recognize these equations when you have a number being multiplied times theta. Okay, so this equation is 2 times sine of 3 theta minus 1 equals 0. Now we're actually going to start these just like we would any other trig function or trig equation, excuse me. We're going to isolate the trig function. So I would start by adding 1. Divide by 2. We're still going to use our inverse trig function, but this time the input is 3 theta and the output is 1/2. So when we switch our input and our output, we'll get inverse sine of 1/2 equals 3 times theta. Okay. Now we're going to go ahead and evaluate our inverse trig function. So we're going to think back to our unit circle. Where is sine equal to 1/2? Well, sine is going to equal 1/2 at pi over 6, but also at 5 pi over 6. And again, that would come from taking pi and subtracting pi over 6. Okay. All right, now you guys notice how I'm setting these equal to 3 times theta. All right, so far we've done nothing different, okay? We've isolated the trig function, used our inverse trig function. The only difference is we're not finished because we haven't solved for theta yet. We still have 3 times theta. So we just have one more step. We've got to get theta by itself. So to do that, I would probably just multiply by 1/3 on both sides, you know, just to get rid of the 3 in front. Okay, now, when you solve for theta, you have to distribute the 1/3, okay? So 1/3 times pi over 6 will be pi over 18. But 1/3 times 2n pi, we can just write that as 2n pi over 3. Okay, and then over here, distribute the 1/3, we'll get 5 pi over 18 plus, and then 1/3 times 2n pi becomes 2n pi over 3. Because, guys, multiplying that 3 times theta, if you think back to when we were graphing these, 3 is your value of b. And so, remember, b is going to change the period. To find the new period, it's going to be 2 pi over b. And notice that's exactly what we ended up with. We just, you know, included an n there, but we've got 2n pi over 3, which is our new period. So, okay, well, let's look at one more example of these. And this time, instead of multiplying theta times a number, we're dividing theta by a number. So we've got square root of 3 times tangent of theta divided by 2 minus 1 equals 0. But again, we're going to start by isolating the trig function. So I'm going to add 1 to both sides, bring down, divide by square root of 3. Okay, we're going to get tangent of theta over 2 equals. Now, you probably want to rationalize your denominators, so you recognize this value from the unit circle. Okay, then we're going to use our inverse trig function. It's just going to equal theta over 2 instead of just theta. And then we're going to think to our unit circle, where is tangent equal to square root of 3 over 3? Well, that is actually at pi over 6. Now remember, tangent repeats every 1 pi, so we're just going to add n pi. But then we're not finished. We still got to get theta by itself. So to undo the theta divided by 2, we'll multiply by 2 on both sides. And then we'll distribute the 2 over here. Now, pi over 6 times 2, this is like 2 over 1, as fraction, is initially going to be 2 pi over 6, but we can simplify that to pi over 3. And then 2 times n pi, we can just write it as now 2n pi. Okay. Okay, you guys. The next scenario we're going to look at is when we have to use a trig identity. Okay. So in this equation, we've got 1 plus sine theta equals 2 times cosine squared theta. So, you know, I'm noticing that we've got 2 different trig functions. And even if I did set the equation equal to 0, I couldn't factor it the way it is right now, you know. So, like, I'm just kind of going through my mind and eliminating the other methods that we looked at so far. So, if you can't factor it, then think of something that we can replace cosine squared theta with from our basic trig identities. So I'm thinking Pythagorean identity since the cosine is squared. And if you remember our Pythagorean identity, you know, which is sine squared plus cosine squared equals 1, we could solve this for cosine squared by subtracting sine squared on both sides. Okay, so we'll replace cosine squared with 1 minus sine squared. At least that way way, we only have one trig equation, one trig function in the equation. Like our equation is now only in terms of sign. So that's going to make it easier to solve. All right, so let's try to clean this up a little bit. I'm going to distribute the 2. Okay, and now this one is looking to me like a factorable equation, just because now I'm seeing the sine squared and the sine. And so why don't we go ahead and set it equal to 0. So I'm going to add the 2 sine squared, okay, and bring it over here. Okay, I'm going to keep the sine theta on the left, because I am trying to move everything to the left. And then I'm going to subtract this 2 from the 1. So that'll give me minus 1 equals 0. All right, so you guys, this is one that we can factor, but we're going to have to start by multiplying the 2 times the negative 1 to get negative 2. Okay, and then we are going to break this up into our 2 factors, each one starting with sine theta. All right, we're going to think factors of negative 2 that add to 1, because 1 is our middle coefficient. Okay, so that would be positive 2, negative 1. Okay, but we're not finished. We then have to divide by 2 to undo the fact that we multiplied by 2 in the beginning. Okay, so we're going to get sine theta plus 1, and then sine theta, I'm just going to keep it minus 1/2, because we are now going to set each factor equal to 0. We'll split these up, and then we'll just solve each equation separately. Okay, now sine theta plus 1 equals 0. We're going to subtract 1 on both sides. Okay, use our inverse. All right, and we're going to think back to our unit circle where sine equal to negative 1. That would be at negative pi over 2 plus 2n pi. All right, and then here I'm going to add 1/2 to each side. We're going to get sine theta equals 1/2. Okay, use our inverse. All right, and then we're going to think to our unit circle where is sine equal to 1/2. Well, sine is 1/2 at pi over 6. And then if I do pi minus pi over 6, I'm going to get 5 pi over 6. All right, guys, so these are all the solutions to that equation. Okay, now, one last thing to show you. So this is just another strategy that you can use if all else fails. So, like I'm looking at this equation, and we've got sine of theta plus 1 equals cosine theta. You know, it's one where we're not going to be able to use factoring. Everything is already in terms of sine and cosine. You know, neither are squared. So what we could do is, in order to be able to use our Pythagorean identity, what if we square both sides? Okay, so if we square both sides, now sine theta plus 1 squared, remember that means sine of theta plus 1 times itself. Okay, so we're going to have to FOIL that. Now cosine squared of theta, we can just write like this. Okay, so let's FOIL the left side. We'll have sine squared theta from the sine times sine. Sine times 1 is sine. 1 times sine is sine. And 1 times 1 is 1. All right, we can combine our middle terms. 1 sine plus 1 sine gives us 2 times sine. Okay, so similar to what we did in the last example, we still are dealing with 2 different trig functions. If we can get it down to a single trig function, then it'll make factoring easier. So why don't we replace that cosine squared again with 1 minus sine squared? Okay, so now this is looking like something we might be able to factor, but again, we want to set the equation equal to 0. So we're going to subtract 1 on both sides, which actually those are going to add to 0 or cancel. I'm going to add the sine squared to the left side, so that'll end up being 2 times sine squared plus 2 times sine equals 0. And so we can factor this, but this is one where we're going to factor out the greatest common factor. It looks like we can factor out 2 times sine theta from both terms, leaving a sine theta plus 1. And then we can just set each factor equal to 0. And then we'll just solve each equation separately. Here we're going to divide by 2. We're going to get sine theta equals 0. We're going to use our inverse to solve for theta. We're going to think to our unit circle, where is sine equal to 0? Well, sine is 0 at 0 plus 2n pi, which you could just write as 2n pi. And then over here, we're going to subtract 1. We'll get sine theta equals -1. Use our inverse to solve for theta. Think to your unit circle, where is sine equal to -1? Well, that is actually at -pi/2 plus 2n pi. And these would be all of the solutions to the equation. Okay, so again, these are just some different strategies that you might try when you're solving some of these trig equations. All right, you guys, we will practice this in class. As always, thank you for watching and have a good night.